morning. Today we're going to talk about logic and reasoning, the second unit in our geometry year. Today is not a lot of math per se, not with numbers. This is more thinking and logic and using our reasoning capabilities. So what we're going to start off with are some pretty basic definitions. You will need to know these two first definitions, actually all the things that have arrows in the first day's notes you're going to want to make sure you know. But there is a definite difference between inductive reasoning and deductive reasoning. Inductive reasoning, and I'm gonna go ahead and write this out, and I'm not gonna make you watch me do it. There we go, that looks a little better. So inductive reasoning is a process that includes just looking for patterns and making generalizations. Inductive reasoning might be, I'm walking through the grocery store and I conclude that there's a senior citizens discount because everyone that I see, it looks to be over the age of 65. That would be using inductive reasoning. We use inductive reasoning a lot, and you've seen a lot of it. Inductive reasoning is used when we are given a figure or a set of figures, and we're just asked to make a generalization about those figures. So, here I'm noticing that the figure has been split vertically, and the bottom has been shaded. Here, the vertical split has been horizontally split one time, so I've broken it into two columns in figure 2. Bottom left is highlighted. In this particular figure, I notice there are 3 columns, figure 3, the bottom left is shaded. So I might conclude that in this one, I still need my vertical, but maybe I have 4 columns and still the bottom left is shaded. So that's how I would use inductive reasoning. There's nothing that guarantees that my conjecture is correct, but it looks to be pretty plausible. I might say this, I might describe it as vertical split with figure number of columns and bottom left shaded. So that might be how I would describe those figures. In example 2, these I suspect you're pretty good at. You could make a conjecture about what's happening to these numbers. First thing I notice is they're all negative, so I don't need to flip-flop between negative and positive. And I notice each one of these is multiplied by 4. So here I did times 4. 4 times 4 is 16. 16 times 4 is 64. So in the past, you might have seen this as written as 4n, 4 times the figure number, or you could just write it as multiply by 4, however you particularly like to describe it. And that's all, both of those examples are using inductive reasoning. There's another kind of reasoning that I would like to show you, and that is called deductive reasoning. Deductive reasoning was made most famous by Sherlock Holmes in his shows, and if you watched the modern day Sherlock, that would be another example. Deductive reasoning is a process that uses only facts and definitions and properties and laws and logical arguments. In theory, most of our court system is based on using deductive reasoning. It might seem like someone did something illegal, but if you can't prove it using facts and definitions and DNA and all of that good stuff, then person in our system is presumed to be innocent. That all is based on deductive reasoning. All right, for the rest of these, I think I have given you the definitions, and we're just going to work through some examples. There are lots of different kinds of ways to present logical arguments. One of them is with conditional statements. A conditional statement is just a statement similar to "it is raining outside" that can be written in an if-then form. And typically we see it in the logic world written as if P, then Q. Here is an example for us. If it is snowing, then it is cold. And this is a conditional, it uses if-then. There are 2 parts to this conditional. The first part is called the hypothesis. And it is always it always follows the word if. The second part to a conditional is called the conclusion. and it always follows the word then. So in our example up above, the hypothesis would be, it is snowing. And notice I did not include the word if. That is not part of the hypothesis. It's just, it is snowing is the hypothesis. And then the conditional part, or the conclusion part, would be, it is cold. And so we're saying that if this first part is true, then the second part has to also follow, which may or may not be the case. Let's look at an example. In this particular case, we're going to rewrite this as a conditional. It says, a car with poor brakes is a menace highway. So I might write this. I always include my word if, and then I'm going to do my hypothesis. A car with poor brakes, and then I'm going to put in then, and this is not a good, I dropped my pen. This is not a good grammatical sentence, but it is a conditional. If a car with poop, that's funny. If a car with poor brakes, then it's a menace, too many, on highway. I teach math, I don't do English. Okay, so in this case, we made it a conditional statement. We said, if a car has poor brakes, then it's a menace on the highway. All right, so we're going to do a lot with conditional statements this year. Hopefully they will come pretty intuitively. All right, there's a different kind of statement that we can create based on our conditional statements. We can write a converse, and a converse is created by swapping the hypothesis and the conclusion of a conditional statement. So in this particular case here, I would just swap the blue words and the orange words. That would make it a converse. I think of it as like Converse shoes. You can switch the shoes, and truly people who see you on the street would have no idea you flipped the shoes. A strange analogy, I agree. Okay, so in example 2, we are being asked to write the converse of these two statements. The first one is the one that we saw up above in the definition of conditional statement. And we identified up there that this is our hypothesis, and this is our conclusion. Again, reminding you that we don't use the word if and then when we identify those parts. The converse of this would then be if, and I'm going to do orange because the conclusion comes next, it is snowing. Then I follow with my hypothesis. It is cold. And anytime we look at a conditional or any form of a conditional, we can ask ourselves, is it true or is it false? So if it is snowing, does it have to be cold? I'll let you decide that one. The next one, the hypothesis is an angle measures 120, and the conclusion is it is obtuse. So if I'm going to write this as a converse, I would say if, and I'm going to move the words around just a little, an angle to make it more linguistically sensical. So if an angle is obtuse, then, and you didn't have to rewrite this, you could have just written it as it was, and then it measures 120 degrees. So I said, if an angle is obtuse, then it measures 120 degrees. You could also have written the converse as, if it is obtuse, then an angle measures 120. And that also would have worked. It's just harder for my brain to process. So now let's determine the truth or falsity of this statement. If an angle is obtuse, we're saying it is obtuse, then does it absolutely have to measure exactly 120 degrees? That's the question. I'm going to argue that that is a false statement. And when we decide that a statement is false, then we are compelled to create a counterexample. And a counterexample is just going to be, in this case, perhaps a quick description of an angle that doesn't measure 120 degrees, but is actually obtuse. And as you can guess, there are lots of them. So my counterexample would be an angle that perhaps measures, well, choose your favorite number. It could measure be 6 degrees, or measure 152 degrees, or it could measure 120.001 degrees. All of those are counterexamples, and to prove a statement false, you need but one of them. The next one we're going to look at is negation. Negation occurs when the word not is just inserted into a statement. So we're going to negate this statement. We're going to say the sky, if the statement says the sky is blue, the negation would be the sky is not blue. And that makes it a negation. Little kids are particularly good at doing negation. Your sweater is on backwards. My sweater is not on backwards. You're on my side. I am not on my side, your side. Kids do it all the time. Inverse uses negation, and that's why we spoke about it. An inverse is when I take a conditional statement and I negate both the hypothesis and the conclusion. So I'm going to add the word not twice to my statement. We're going to do an example here. If it is snowing, then it is cold. We keep going back to that example. We know that this is the hypothesis, and we know that this is the conclusion. If I'm going to write the inverse, I would say, if it is not snowing, and I'm going to do that in a different color, so I left a space. I'm going to put the word not, and then I'm going to follow it with the conclusion. Then it is, again, leaving, that was supposed to be orange. It is not cold. You get the point. And now I have created an inverse. I do that by adding the word not to both the hypothesis and the conclusion. Okay, is this true or is it false? If it is not snowing, then it is not cold. I argue that this is a false statement. I argue that it can be below 0 and sunny. And I see pictures of that all the time on National Geographic or the Discovery Channel. One last one. There are 4 different forms a conditional statement can take. And the last one is a contrapositive. And it's sort of a collection of all the different things we've done so far. A contrapositive is formed by negating both the hypothesis and the conclusion of the converse statement. And the order that you do these in does not matter. You can write the converse and then negate it. You can write the inverse and then do a converse of it. I kind of do everything all at once. We're going to do an example. If you are a sophomore being the hypothesis, then you are in 10th grade. You are in 10th grade is my conclusion. When I write the contrapositive, I'm going to write the orange words and then the blue, but I'm going to put the word not into both statements. If, and now I'm going to go orange, you are, again, I left room for the red word not because that's what I need to do. I need to negate it. If you are not in 10th grade, then, and now, then how I do my blue words. You are not you're not a sophomore. So I switched them and I added the word not, and that creates my contrapositive. To determine whether it's true or false, I just need to come up with a counterexample. So ask yourself, is there a time in my career as a student when I will be a sophomore, but not in 10th grade? I'll let you think about that one. I'll tell you the answer in just a moment. All right, we are going to jump to example 7 to conclude our lesson. And we're going to just write all the different kinds of statements given this conditional. If AB plus BC equals AC, then B is between A and C. And you'll recognize this as being the segment addition postulate. We're going to identify the hypothesis and we're going to underline it once. We're going to underline the conclusion twice. And then I task you with writing the inverse, the converse and the contrapositive of those, I am going to be lazy and show you my example that is already done. And I went ahead and wrote them. The converse would be, if B is between A and C, then AB plus BC equals C. The inverse goes back to the original condition and says if AB plus BC does not equal AC, then B is not between A and C. And lastly, the contrapositive, if B is not between A and C, then AB plus BC does not equal AC. And then lastly, here's my counter example to our contrapositive from above. I conclude that if you are not in 10th grade, you are not a sophomore is false, because I think you can be a sophomore in college. That's it for today, folks. You are now well versed in the worlds of logic, sliding papers, and reasoning. See you soon.